Hello, everyone. My talk gives a brief guided tour of a pretty dense paper. Placement is central to physical design because it determines the spatial embedding. And placement is never in isolation. It is conjointly optimized with logic, clock and power distribution, and other products of other PD steps. There's a great background survey, which I tried to not repeat, by Markov, Hu, and Kim. It gives the state of placement research up through 2015. There have also been 14 academic placement contests over 16 years, beginning, of course, with the very first ISPD contest. So after 50 plus years and 14 contests, what can be said about advancing placement? What's left? And the answer is a lot. The paper calls out challenges in fundamentals of placement optimization. The need to turn to research where placement is co-optimizing and co-operating. New foci for research, many of which are actually old, but newly urgent to address. And then the nexus of learning and placement, support for placement research, and conclusions. Let me flash a couple of slides from the talk. In any convergent top-down flow, we want estimates and predictions to be accurate. So just this GIF motivates some challenges of how to make predictable, stable, and smoothly behaving placement optimizers. There are some new foci for placement in the near future. This slide shows island-heavy placement at the Foundry 3nm node, which is a result of trying to scale both density and performance. How can we extract maximum value from a fabric like this? We'll also see more extreme memory dominance. The right-hand picture has nearly 2,500 macro blocks. Another old problem that is new again, especially with AI chips, is data path place and route. We need automation that can achieve this kind of custom scripted QOR. There's a section on machine learning and placement. This slide gives a few targets at this nexus. Learning objective functions, steering tools, embedding, and clustering are among the key directions for future research. And with machine learning for placement, we need to understand limits on applying our ML models. For example, what do we do when acting on a prediction changes the predicted outcome? And that's what's shown here. Using a predicted placement outcome changes the placement solution so that it's not what we actually predicted. And I'll talk about infrastructure for placement research, such as IEEE CETA DATC's robust design flow, which integrates academic tools into a freely available RTL to GDS flow. With placement co-optimizations and co-operations, this is an important backplane for research. Another part of support for future placement research is infrastructure for data collection from machine learning. We can't share commercial tool scripts or log files or models with each other. So how can the leading edge of research become visible? This is a repo, Metrics for ML, that is also in the DATC's GitHub, and that has some initial efforts. Please see the talk video, and I hope to answer your questions on Monday. Thank you very much.